Greetings, everyone, and welcome to the explanatory companion to the software landscape vision board. This video is a journey, partially my own personal journey through the software space, with the aim to provide the context of where did we come from, where are we now, and where are we heading. There's no technical background needed to understand any of this. I will go over most of what you see on the diagram here. So the goal is to be simple, but to provide the overall view. Also, one of the goals is to provide the context to understand the ICP technology, which in my view is a true technological feat, a double innovation in crypto and cloud. But to understand that, you need to go beyond the crypto blockchains of today, and you need to understand cloud. And not many people grasp it because few are actually working within this space. So the engineers, the Web2 engineers understand cloud. They might not understand crypto. The crypto speculators and the crypto engineers might not really understand cloud or partially understand cloud. They're more kind of involved and focused into the crypto projects. And so there's this kind of unification missing to unite the Web2 and Web3 to understand both. And this is the aim of this diagram and this talk. So before we go into this, I would like to give you a small overview of my own personal software career. Again, this is a journey, and so my own journey will help you realize what kind of steps I had to take to build global software. How is global software being built? And just to kind of provide you with some background of myself, because this diagram didn't come to be just because of imagination. Like, there's actual experience behind it. And so let's start with an overview of my own career. So this is LinkedIn. It's publicly available. I had a roughly 10-year software career, which ended 2 years ago. I'll go into the details why it ended, but I had a wonderful career in my view. I had a lot of opportunities, and I was able to be part of great teams, build massive systems, and throughout this 10 years, I was able to always have opportunities to take on the next challenge. So initially, I was just a junior software developer. I really concentrated on being the student and crafting like a good, clean code. So that was kind of my main objective. My team built a new module for a major, I would say, legacy banking system. And I also had an opportunity to improve a UX for Nigeria governmental booking system. So different projects where I was like learning and obviously had supervisors who were looking at my code, but I was already involved in like pretty big projects. Then with a couple of team members, I left and joined a startup. Here I would say that the key experience for me was peer programming, which is also called extreme programming, because it is pretty extreme. It's intense to actually code with 2 people. And we did that for over a year. And that really kind of accelerated my growth, being in this intense environment with a senior developer. Very useful, and I appreciate the opportunity there. And we worked for a major telecom company, building tests, building new functionality for the business side. Then after that, I joined LHV Bank, which is like a fintech bank in Estonia. And I was a lead developer for my team, but also taking part in the overall IT strategy, building the first API for LHV Bank, but also like mostly being involved in the merchant side. So payments coming in and then kind of processing that and sending money to the merchants. And then that was kind of half of my career. And then the other half was in Twilio. And this was really like the cherry on the cake for me, because Twilio was a fastly growing company. When I joined, it was 650 people. When I left, it was 6,500 people. So it 10x'd, and everything really 10x'd, including the systems and kind of the overall infrastructure of the team, of the company. And Twilio was a cloud native. So everything was built on the cloud. It was using AWS. And this was my first opportunity to work with the cloud. I've heard about it before, but I didn't really use it. And it didn't take long for me to understand that this is awesome. Cloud is extremely empowering. I'll get into cloud afterwards. But here I was again, I had a great opportunity to lead, to take a lot of responsibility and come through that responsibility. So first of all, I led the foundation to build a fraud detection service. So it's a near real-time service, meaning that there was a lot of different events coming in. We gathered the events and tried to kind of come up with useful insights, determine whether it's fraud or not. We also used a third-party vendor for that. So there was different services, different databases. We were notifying the operational people. And so a lot of different parts. And really that's where cloud started to showcase itself to me, because I saw how much you can build. You can really build anything with so many different moving parts. And that was like, wow, like cloud is extremely empowering. I then led my team to build like a complex system, which was called like a connectivity catalog, but basically it also aggregated many different events for messages and for voice calls, and combined them together for internal insights, mostly internal insights. I also helped solve a couple of firefights with teams that really had to like fix or improve a certain service for different various reasons. So I was really kind of living this this ideal position where I had freedom. I was technically good. I was leading my team, and I was kind of moving beyond my team. And eventually, my job included not so much coding anymore, but really visioning the next steps, which again, like I really loved. And eventually, I saw that this is what I'm really good at. Engineering was fun, and it was building stuff which I liked. But really building the architecture across teams and aligning my team with other teams, and my team with my business unit, and my team and my business unit with other business units. This kind of really pushed me into this territory where I felt that this is what I'm good at. I had to understand business. I had to understand the technical sides, because the technical system that we had right now wasn't where we needed to go. But also I had to line other systems, in-house systems, and also understand that they're not right now where they want to go. And so it was a lot of this aligning and communicating and visioning and trying to vision my system, but also other systems, and aligning that really fun stuff for me. But for two reasons, mainly two reasons, I decided to end my career at the top. So for me, that really seemed like exiting at the top, because obviously I could have gone further, but being a senior staff engineer, senior tech lead, I just saw that moving forward, the benefit is not, it's just not worth it anymore. And also I wanted to build stuff outside of software, which I went on to doing, building a reality model, base reality model, and also building like a consciousness school on top of that with my wife, and we're still kind of doing that. So yeah, I wanted to move out from software, try out other stuff, gardening, as you can see from the background. So kind of get exposed to more life. But the other side was that being in this position of engineering at like one of the top companies in the world, utilizing cloud fully, building whatever is possible, I suddenly saw, and it was really like an awakening moment where I saw that what we're doing right now is essentially what other companies are also doing. And not a few companies, but actually tens, probably hundreds of thousands of companies who are building on the traditional cloud. They have to go through some motions. And I'll get into the details afterwards. But what I saw is that we're basically reinventing the wheel tens of thousands of times. And the services and the work, the energy that we put in globally, there's a lot of waste there. So I just saw that the software space globally has a lot of energy waste, even though for a company, it can be relatively clean. And I just didn't want to be part of that anymore. I wanted to harmonize reality, myself and my surroundings. And I didn't really see any other way. Like the cloud seemed to be the not even the current thing, but almost like the next thing. There's a lot of legacy systems and companies and governments that still haven't moved to cloud, with actually somewhat good reasons. But I just like I didn't see any other way. So I decided to kind of move away. I planned my exit for 3 years. So already 2018, I saw that, okay, I roughly 2021 or at the start of 2022, I'll be moving on. And so that was kind of my path was set there. But right before I moved on, I found ICP, the Internet Computer Protocol. And that was eye-opening. It was shocking, actually, because it was such a powerful realization, even more than learning about Bitcoin, which I'm also passionate about. But finding ICP was like really close to my heart because I was involved in software engineering. And Bitcoin, while it is a monumental tech, it's not all the software. It's still like it's very nuanced and very niche, and there's great powers in being that niche, but software is much bigger. And so when I found ICP, it was just amazing, and I'm still excited and almost at loss of words. And so I've been thinking about ICP for 2.5 years now. I discovered ICP 2 days before they launched. It was 2021 May. And I've been trying to wrap my head around it and trying to describe it for myself in a simple, using kind of the simplest models possible. But at the same time, it is a huge technological feat. And so the simplicity that I'm after is really kind of elegant simplicity, not just simplicity of saying something which nobody gets. So I've tried to kind of build this whole view of what really is the behind this innovation of ICP. So that was my personal journey, and as I said, I've been following ICP for 2.5 years. When I discovered it, I immediately, in my mind, I immediately framed it as a crypto cloud. That was just, for me, the simplest approach. The Internet Computer Protocol didn't really, like, I resonated with it enough, but it didn't really kind of connect with me. A lot of talk was about the world computer, etc., but it was a bit too abstract for me. But CryptoCloud immediately clicked for me, and so I wrote about it 2 years ago now, December, February. So this is like 2 years ago. I wrote a trilogy for the CryptoCloud, and so the first part was about the crypto ethos, which is really about the principles, not really about different blockchains, but the principles behind the crypto movement. Then I talked about the cloud, and really like the mighty cloud, how much it empowers engineers to go out and build whatever they want. But at the same time, the kind of the drawbacks and stuff that is happening behind the curtains that you as an engineer and as a company don't necessarily acknowledge. Building your software, you don't really see that what you're doing is, to a large part, what everybody else is doing as well. So the value proposition for a company, the effort for the value proposition of the company is not as high as you would want to think, especially when you grow. The cloud configurations and the different aspects, they really grow. And if you multiply that by 10,000 or more, then you see that this way of building software and cloud is empowering the internet. This way of building is not optimal. It's not the greatest way for humanity, for the energy use. So I wrote about that. And the third part was the crypto cloud. So what if we actually unite those two? We unite the deep principles, the new way, fundamentally new way, open way to build software, and the powerful notion of the cloud. What if we unite that? And that's ICP. That's the Internet Computer. That's the cloud protocol. So we take the useful aspects and we also solve many of the different problems of the cloud at the protocol level. I'll get into this as we watch and go through the diagram. So yeah, I wrote about it, but I still was trying to make it simple and describe it in different ways, trying to educate and do my part in the crypto Twitter. And ICP has just keep on proving itself. So at first it was just an idea, a powerful idea, and a vision, but it's been now 2.5 years, and it's grown and it's added pieces that are just not possible anywhere else. All right, so that's a brief introduction for myself. I didn't come up with this diagram just out of the blue with my imagination, but I actually have some expertise in building software, and I've used the majority of the tech, or at least the meat of it. I've actually personally used, not as a pet project, but as a highly reliable mission critical services in a global company with a high throughput. So a lot of data going in, etc. Okay, so let's try to understand this diagram, and first let's kind of do the same journey that we'll look into the cloud, we'll look into the databases, we'll look into the blockchain space or the crypto space of now, and then we'll look at the ICP. Maybe we'll cross-reference, but that's kind of the path that we're going to go. Okay, so cloud hosts the web. Backend, frontend, data. It enables running parts or end-to-end software. It contains full stack software infrastructure. So basically, the cloud is like a container, and you can put different parts into that container. But the powerful thing is that this container enables you to build anything. So you can have APIs, you can have different asynchronous processes, meaning that stuff will just either get called from the outside or just internally. Things are kind of waking up and doing something, and different processes going off. You can really do whatever you want. And so it's really empowering, really empowering. But the way this whole thing is set up, and it's not like a conspiracy theory, it's just like cloud was built, and kudos to those companies that kind of seized the moment and enabled this empowering technology, this container, the cloud container. And the problems kind of just emerged from there. So if you get this empty space, you need to do a lot of stuff for it to actually be useful. If it's for a school project, then you can just put a server here and voila, you have a service. It's publicly available service. But if it's actually like a company with actual users, thousands, tens of thousands, hundreds of thousands, millions of users, then it's a lot more complex. And there's a lot of different areas that you need to solve for your overall system to work. And so some of the stuff like this generic problems I have brought out here. Let's just briefly go over them to get some ideas. So first is the security. And the thing with the cloud is that you do get this container, and the novelty here is that you don't have to think and manage the physical devices. So how the internet was built before cloud was that you either literally you own the servers in your house, or you used some node providers, but you managed the servers. So if something happened with the servers, it's on you. You have to like order new servers. Also, scalability was kind of difficult, because if you suddenly get more traffic, you have to buy new servers. It might take months. So you have to have like surplus, and it's not efficient, but you had a lot of control. Then cloud came along, and you didn't suddenly have to think about the physical servers anymore. Now you had virtual servers, and you can boot 10,000 servers and just use them with a click of a button. It's very, yeah, as I said, empowering. And the security of the physical devices is outside of your worries. So that's good. But the security of the container is on you. And so you need to make sure that the firewalls are set up, that whatever security keys, private keys you use are securely handled. Access management for your employees, for your users, a lot of different stuff. And unfortunately, the way this kind of traditional cloud or centralized cloud, or even in a way like private cloud, but cloud with a centralized intermediary, it's not just Amazon and Google who are kind of centralized intermediary, but also the company itself and the employees are centralized intermediaries. They are single points of failure. And when you have an account in one of those Google providers, usually, or probably always, there's no other way. Maybe there are, but the way it's usually done is that there's this one root account. Usually that's the CEO. And if you hack into the account of the CEO, you can basically just delete everything. You can do a lot of damage. Usually that's done through social engineering. But even if you hack into an employee account with engineering access, you can still do a lot of damage. You can delete data, you can steal data, you can deploy stuff that shouldn't be deployed. So you can install malware, a lot of stuff. And while you can mitigate some of the risks, you have to have very strong security teams, again, like the effort to do that. And you can never be 100% sure. So yeah, there's a lot of manpower or engineering power needed for that, and it's always a race, and it's quite like nerve-wracking. Then there's this other things outside of security, but actually making sure that you fully utilize the power of the cloud. One thing that cloud really enables is elasticity. So your services can grow and shrink depending on the load. Again, you have to set it up, but there's different services and configurations that you can set. And so then your service can, for example, the fleet of the nodes can increase depending on the time. For example, in the morning when there's more traffic, you have more servers, then you shrink the fleet. Also, you can just monitor the traffic and scale depending on that. There's the server recovery. Also, load balancing is like there's different mechanics. How do you direct traffic? Some servers just die, so you have to make sure that your services are able to boot up and constantly, like if you have, like let's say 10 servers and one of them dies, it just automatically reboots the new one, and again you have 10 servers. User data is also like a very broad topic and a delicate one. I'll talk about data in multiple parts of this walkthrough, but basically with user data, this needs to be secure. There has to be access management. Like your own employees shouldn't see all the data. So it should be gated. You should only see the data when a customer needs for you to see that data. Also, just moving around data. There's different jurisdictions. For example, in EU, with GDPR, you shouldn't move data outside. So again, like if you're building small services, school projects, doesn't really matter. But if you're building global companies, global software, then it's very nuanced and complex to actually configure all of that. And all of the companies have to do that. So we have to solve all of that 10,000 times, even though like essentially it's a generic thing that could be solved. Or I'll just throw the question, like, what if all of this can be solved? What if these problems can be solved at the protocol layer? So not cloud, but cloud protocol. It's a what if? And then there's different databases, data buses. So data bus is a way to move data from one place to another, also to have like near real-time services. So a lot of data is moving in different directions, basically events. And so the events are flowing through this data buses. That's how they are called. And regional data is something that I already touched, but that's the thing where you have to have different data across regions. So you just can't have a single database, but one has to be in EU, one has to be in US, maybe one in Asia if you have a global business. A lot of stuff. And so the IT personnel here, what's really the efficiency here? And that's what I also started to think about, the work that I did as an engineer and seeing my fellow engineers in different like teams. Some teams were just only focused on the infrastructure, just kind of maintaining some of the stuff, building internal tools for these. Imagine like all other companies have to do the same. They somehow need to manage that. But even as engineers who weren't in the infrastructure team, we still needed to know all of that, not just like theoretically, but hands-on. We had to like really know all of that stuff, and that takes energy to learn and to use, to configure. How much effort is it? It's difficult to say, but maybe like half. It's not like 5%, like maybe half of the effort goes into maintaining the cloud, and half, or even less, there's meetings and other stuff as well. Maybe like 25% is actually coding the actual functionality. So there's this slide in Internet Computers cloud deck, which estimates the IT personnel cost. This is obviously growing, and I would say that it doesn't also include many of the other costs like hacks and ransomware that is also just ballooning. And so we can really reduce our spending and just not just money wise, but energy wise, engineering minds, and also just pure energy and time. We can do a better job globally. And this is something that I just didn't know when I was working in, and when I saw the problem, but it didn't seem any good solution. I didn't see any good solution. And when I discovered ICP, I just realized that CryptoCloud is the next way. It's the evolution of cloud, and cloud is powering the most of the software that is being built today. Right, so that's cloud. Empowering plus problems, which means big business, and that's why they are the big tech. They give you a lot, but then they also like create not like they don't do it consciously. It's just the way it's set up, how this centralized cloud is set up. And so yeah, that's how most of the software of today is being built. This means backend, front-end data is contained by this cloud. But if we now zoom in to the data, and let's maybe pause here. Why am I talking about these different components? Is to give you an idea of what does it take to build an application that you can use. So the Facebooks and the Twitters, these are like maybe a few big examples, but all other tech, all software, this is how it's being built. It's hosted on cloud, and there's the data side, which is at the core. Then there's a lot of functionality, like backend functionality around it, what to do with the data, how to surface the data, and then there's the UX on top of that. So these are the necessary components. And it will become more clear when we get into the crypto space and understand like what are the blockchains doing and what are they not doing. And so it will become, it's a journey. So bear with me. So this is the data side for Web2 engineers. This is how you build globally scalable software. So data architecture, some of the things that you need to think are the data ownership, access management, long-term storage, near real-time derivations. So basically what you would do is you would choose a database engine. Here are some of the examples. These are relational databases. There are also like NoSQL databases, but basically it's to store data, to store transactional data. So what I mean by that is that you don't really store pictures and videos like media files in those databases. It's just to store information that you can query. And again, like if it's a school project, then you just like you use, for example, AWS, you boot up one machine, you install MySQL there, you create a table, easy. But if it's a big project with a lot of data, then you have to, again, go complex and solve many of the problems that big data kind of needs. And granted, the cloud providers, they whenever they see a problem, they will come up with a new service that can help with that problem. So there's also like cloud provider specific database engines where you don't have to deal with all of that. Like partially it's provided by the cloud provider, but you also again like lose some of the flexibility and the control with that. You cannot easily move from one database to another. If you kind of if you choose a database, it's better to choose it for like 5 to 10 years. And if you have to move, then just build a new service, new database from scratch. Because you have to optimize the databases, like index databases. Every database engine is different. So again, you need to understand them thoroughly. And so I've used all of those databases, but not in equal proportions. Likely MySQL I have used the most, but I do know that all databases kind of have their own nuances. And so how do you scale a database? Well, mainly it's using the main replica architecture. And that means that you separate the writes and the reads, which allows you to actually scale the reads, have many more reads, and you write into a single place. When you have also many writes, then you need to scale the writes as well. So you need to kind of partition the writes, and for each entry, you determine, let's say you have like 10 different write servers. So a new entry comes in, you do some calculations on top of that entry, and you determine whether it goes to this second partition or seventh partition, but you can kind of determine always for each entry where it should go. And from the write machines, it would be broadcasted to the replicas that can have like hundreds of servers that you can read. It's a complex thing. Like first it's just setting it up, but also making sure that that the reads that are coming in should always get the same response. Or let's say 10 reads are coming in almost simultaneously, but also one write comes in. And like, how do you handle that? Depending on the business, it can be more crucial or less crucial. It's a complex stuff. Like you have to really go deep into it. Then there's again, regionalization. So we can't just have one database. We have to actually separate the databases, which is again, like it kind of sucks, because when you want to derive like global insights, then you need to combine those databases together, perhaps lose some of the information, but you still need some sort of business metrics. And so you have to combine them together. Again, complex. It's partially related to archiving it to long-term storage. So again, if you have a lot of data, then this relational database doesn't necessarily have to contain the full history. maybe it contains like this year or maybe even less, and everything else will be kind of packaged together and sent into this like long-term storage where you can run some analytics on top of that, but they're not really within the flow of your business because it's just too slow to query this kind of big data. And then there are L2 aggregators. So I specifically kind of worded this in this way. In the Web2 world, it wouldn't be said that it's an L2 aggregator. But I did it to kind of already connect it to the crypto space, because what this is essentially is an L2 on top of the L1. And so when L1 is good for reads and writes and different like medium queries, it's not, again, it depends, but it's not necessarily great for like full text search and for really kind of near real-time data. And so for this, there are different tools and technologies like Cassandra, Elasticsearch, Spark Streaming. And essentially what these are is that they index a portion of the data. So let's say this database engine holds 1 year of data. In the long-term storage, we have like the full history, 10 years, 20 years, whatever. Here, we might have like a day worth of data, or maybe a few days, maybe a week, but it's all indexed basically in memory. And you can do various searches, like full text searches, like give me all users that have a letter A in them, like stuff like that. Also, what you can do here is you can pre-aggregate data and then perform queries on top of the aggregates. So, for example, you can pre-calculate averages, like hourly averages, for example. And then if you need an average, then you just average the averages. Instead of always, if you need an average, always just do the full average calculation, which can be time consuming and energy consuming if you have a lot of data. So there's different reasons why you would need this L2. And this is, again, kind of keep that in mind when you think about the L2s in the crypto space. But we'll get there. So that's the way the Web2 engineers build software today. And when it comes to the crypto blockchains, then essentially it's a new kind of paradigm for this part, for the databases. Because right now, the developers, the engineers, the company is using MySQL, for example. They are controlling the database. They are also controlling the kind of their kind of cloud. And first of all, that's a single point of failure. Second of all, they can do whatever they want with the data. Third of all, if they are hacked, then this data will be compromised. So the novelty of the blockchain space of today is to decentralize the databases. So this is a centralized database. Here we have decentralized databases. Okay, now this might not be a way how you previously thought about blockchains, but at the same time, it kind of must be, because blockchains are databases, they're decentralized databases. However, you hear this all around, people saying built on Ethereum, built on Solana. And this is not really completely true. Like, partially, yes, they use Ethereum or Solana or the other tokens. They use it for storing and transacting tokens. So for transactional data, they use it, but the application itself, there's more components at play. And so most of these are hosted on the AWS, the Google Cloud, the other cloud providers, meaning that the applications, the decentralized applications, are not really decentralized because they're hosted on centralized cloud providers. But let's look into the blockchain. So here I kind of separated Bitcoin from the rest because for me, Bitcoin it deserves to be in a class of its own. And that's where it all started. Bitcoin is a transactional truth ledger. And both, like all three words, mean something. Transactional meaning that the information is not like information is really nuanced. It's moving an asset from one place to another. And that's it. There's tremendous power in doing that, especially if it's like incorruptible, globally distributed. This is a new novelty in accounting. Also, for me, Bitcoin is connecting the physical with the digital. I feel like that's a necessary thing to do because we're getting into this digital realm where there are no limits. And I feel that there has to be an anchor. And for me, Bitcoin is that anchor. But as great as it is, it's not enough to include the whole finance, let alone the whole software. And this is, again, something that's really kind of missing in the general awareness in the crypto space and in crypto Twitter, at least, is that they talk about DeFi as that's the whole thing. But really, like, software is bigger than DeFi. There's other stuff that needs to be built. And so Bitcoin doesn't solve all the problems, but also decentralized databases cannot solve software as a whole because it's just a database. There's other components needed. So another layer, like for me, like generation 2 blockchain extended the notion of transaction to a contract. So this is like easily graspable because if you think about transaction, it's just it's just a few words. Amount from where, that's basically a transaction. But a contract, you can already see that, okay, a contract is many pages, it's conditions, it can contain different transactions. And if it's on chain, that is, if it's like a global database, there are many contracts, like you can code contracts into this database, but now we're encoding it to a blockchain that everybody can verify. We can do payments, we can do different ownership schemes, we can build novel organizations, the DAOs, at least the building blocks of the DAOs. So that's great. But unfortunately, the Web3 space, it's still maturing, and different problems arose partially because of the technical, that's how technology and that's how everything evolves. You go out, you build something, you see whether it works or not, and then different challenges arise, and then you deal with those challenges. So that's normal. And many challenges have been kind of have come up. For example, this is not the conclusive list, but for example, oracles. So the need for an oracle rose because blockchains don't have access to the outside world. They're kind of this isolated thing. You cannot call from Solana, you cannot call an API or from other chains. And so you needed something in between that could query stuff and then put it on a special ledger And so other blockchains can query that ledger. So you needed some intermediary. And to stay true to the crypto ethos, you needed a decentralized intermediary. That doesn't mean that oracles are like essential. It just means that there was a problem that had to be fixed, and it was fixed. But at the same time, is the problem, will the problem always persist or not? If the problem goes away, then do you need the solution? And this goes to many of the problems of the Web3 space. There's all of these problems, and solutions have come up, and there's also the kind of the nature of the Web3 is ownership. So there's a lot of financial incentive for the solutions to persist. Similarly to how for the cloud, the problems of the cloud are a business opportunity for the cloud providers. In the crypto space as well, there are many problems, and then different solutions come up, and there's a lot of like financial games being played with those solutions. L2, actually, to finish with the Oracle, this is not to say that an Oracle is not needed in the future. I do see that there's like a valid reason for cleans and verified data. And so if that's an Oracle, then that's valid. But to access the outside world, do we need this decentralized intermediary? With ICP, we don't. It doesn't mean that no one will ever need an Oracle. It's just that the nature of Oracle will have to adapt to the new technology. The same with L2s. Like the L2s of today are really kind of battling in the domain of scalability. Ethereum has many L2s. Why do you need many L2s? Well, for different reasons. They come up with different technical reasons why you would need them. But really, it's about scalability. Again, with alternative tech stack, with using ICP, which we will get to, the notion of L2 will have to change, because you don't necessarily need to scale anymore. But that doesn't mean that you don't have reasons to run complex queries and then store those complex queries like we did in the Web2 world. So this is the way things are built right now. It's not inadequate tech. It's the only way to get fast insights from a large amount of data. So L2s, for that matter, are necessary. Whether they're necessary just to scale the L1, that remains to be seen, because maybe there are better ways if we use a CryptoCloud. So another problem is that the smart, like the L1s of today, they are an extension of Bitcoin. So transactions became contracts, but a contract is still like text. So you can literally visualize this as like 5 pages or 10 pages or 100 pages. Like it can be 1,000 pages, but it's still text. It's not a lot of information. If you actually want to store other data like pictures and videos, then just like in the Web2 world, you don't store it in the relational databases. You store it in some other file storages, just for kind of to keep the memory of your main database low, because otherwise, like one picture is more than 1,000 pages of text or something around that. So you cannot really store anything other than just text on those blockchains, which this is important. The NFTs, like what are NFTs? Pictures, right? Are the pictures stored in the blockchains? No, because you cannot. It's just too expensive. You store the ownership on the blockchain, but the picture itself is stored elsewhere. So it's stored in other non-transactional data chains. Filecoin, Arweave, whatever different infrastructures. Or it's just stored in a traditional cloud, where it's kind of the most convenient in a way. If you want to really have a decentralized tech stack, then you would use one of the decentralized versions. But still, the NFT itself that you paid for, the actual thing, not just the ownership, like the contract is on a blockchain, but the actual thing itself is stored elsewhere that you cannot control. I personally don't like that, but that's how the crypto space works, and basically no one cares. Because of the monetary incentives and all the volumes. So some of those blockchains are kind of successful in building large volumes of trading, but really trading on what? They don't even store the data itself. That said, there are niche use cases where you would need these types of blockchains. So I'm not saying that these are like irrelevant technology. Solana has like a very specific use case, the way I see it, like as a global atomic ledger for high volume trading. That's the way I see it. Ethereum as well, like Ethereum could be the ease and could be continuing to be the main platform for tokenization. But this is not all the software. It's one component. Okay, you cannot build on Ethereum. You can use Ethereum. Then there's the centralized custodies, and the main one being the cloud itself. So you use Ethereum, but the application is hosted on AWS or Google Cloud, Microsoft Azure, different cloud providers, centralized cloud providers. This application is not decentralized. There's other centralized custodies, not just custodies, but intermediaries as well, to validate the nodes, and like the actual infrastructure itself is using centralized intermediaries. For example, Infura as a node validator for Ethereum, and MetaMask as the main like wallet for Ethereum, they are either just a centralized intermediary or they use a centralized intermediary. You take both of them away, Ethereum is almost useless. You can use it directly, of course, but it's just, there's no UX. Right now, the UX is using, and the key infrastructure of validating the nodes is in the hands of centralized intermediaries. It doesn't have to be this way. There is a better way using the ICP, but right now that's the case. Bridges and interoperability, well, basically the same thing. If those blockchains want to communicate with each other, they use bridges. And a bridge is, first of all, like it can be a decentralized bridge, but where is it hosted? Where is the front end hosted? Even if the back end is decentralized, it's a smart contract. If the front end is hosted on AWS, then a developer can manipulate the UX, or it can be hacked and then manipulated. You can drain wallets, and it's not like a theory. That is what's happening. So that's kind of that's really a simplified view of Web3. There's different graphs that show different components, and to me, it's just a mess. Like you don't need that many different like blockchains and in a way partially decentralized, but then centrally connected parts. It kind of removes the actual novelty of the crypto, of being a decentralized new approach to building software. So that means that where are we right now? Yes, we're talking about Web3, but Web3 is an ideal right now. In reality, we're in the Web 2.5 era, where we have those decentralized applications using partially decentralized data architecture hosted on centralized cloud. This is the truth. That's almost the only way. If you take ICP away, which is like a unicorn, it's like Bitcoin. Like, how is it possible? And why is no one seeing it? Why is it being ignored? It's because it's completely different. But right now we have this situation, and here basically all of the problems of the cloud and Web3 are present. And if we try to kind of summarize them together, it's the global engineering energy waste. We waste a lot of energy in those like ad hoc solutions. We waste a lot of energy within the cloud providers to setting up your cloud. Hacks, ransomware, for both. For the traditional cloud and for the Web3, there's a lot of hacks that are possible. And also single points of failure, centralized intermediary. So we have talked about this. Present both in the Web 2 world, obviously, but also in the Web 3 world, where partially decentralized, but the connection points, and there is always at least one part that is centralized, and you need only one to get in. So that's where we are right now. Also, that's where we came. So we came from this Web 2 world, and a lot of the stuff that we worked through and that naturally rose from the Web 2 engineering efforts are also present in Web 3. So Web 3 is not that different, although fundamentally it is different, but you still need to go through the same challenges to scale. And that's where internet computer comes into play, which is not crypto nor cloud, it's CryptoCloud. And this is also what I believe the reason why it's getting like dismissed or overlooked and not understood, because it's not your average crypto project. It's beyond crypto. It applies crypto to the cloud, and hence the CryptoCloud. So for me, it's a double innovation. It's just not the next novelty in the crypto space, like within the crypto space, but it's taking the novelty of crypto and applying it to cloud, which is empowering the whole internet. And this is huge. So ICP, officially the Internet Computer Protocol, I also call it as an infinite cloud protocol, so still ICP. But for me, it's sometimes, depending on the context, it's just more accurate to really emphasize that it's a cloud protocol. Also, it's an infinite cloud protocol. That means that it can scale. It solves the cloud problems at the protocol layer. So what does it give to the users or the engineers, the builders? Well, it depends. If you're an enterprise, and by the way, it does seem that ICP might have a different route kind of towards the top, because right now within the crypto space, the attention is just like DeFi, NFTs, different L2s, like different, like there's a lot of noise there. And people just don't see what ICP is, how it's different, how in my view, it's like a clear top 3 coin. When I say top 3, it's like whatever. And there's many projects that claim to be a top 3 coin. So that's not a bold statement. But there might be a different route for ICP through enterprise first, because there are real problems in cloud, and for entities who want to build global solutions, either companies or governments or like cross-government entities, you would want the most world-class enterprise-grade solution, and that's the ICP. And there's very interesting collaborations that have been happening with ICP with different governments and like educational systems, etc. So this is really, for me, this is truly like the next generation of crypto, but also like in a way the last generation, because here Web3 becomes Web 3.0. It's a complete solution. It doesn't mean that we stop evolving further, but here we actually have a solution where everything is on chain, and not connecting many different parts, and like theoretically or in a way everything is on chain, but it's just scattered around. We just have the CryptoCloud. You can use any database, like here you use AWS, for example. You can use MySQL, you can use PostgreSQL. Heck, you can build your own database here. Doesn't matter. You can do that. In ICP as well, ICP doesn't really compete with any other project. It's just, what does Crypto Twitter and Crypto Space do? Well, they start comparing. They start comparing numbers and try to find their way, like how are they better? But really, it's comparing a database to a cloud. It's like comparing an engine to a car. You can do that. It's just not really productive. And so yeah, ICP is not really eliminating the crypto players, but elevating. So if you see value in using, for example, Solana for certain DeFi initiatives, then do that, but host the application on ICP. You get a lot of the power of the cloud without actually using a traditional cloud. You don't get those problems. You get cloud in a protocol layer, but you can use a Solana database. Right now, ICP is not like directly at the protocol layer connected to Solana, but it will most likely this year. But it is directly integrated with Bitcoin and Ethereum. And that's huge, actually, because this means that when we talked about L2s, like for example, for Bitcoin, there's the Lightning, there's Stacks, there's Liquid. These are mainly concerning about the scalability. But this is not full stack. So how do you can use them like programmatically, basically, to interact with the other side. But first of all, there's still the intermediary. Often it's actually centralized intermediary, so you have to trust the channels. But also, where is the application itself stored? Is it the company providing you the application where you can use Bitcoin with Liquid, for example? Is it a wallet that uses that? Well, where is the full software stack hosted? It has to be somewhere. If there's a web page, then it has to be hosted somewhere. And well, where is it hosted? It's either the traditional cloud providers or ICP. The difference is that if it's hosted on ICP, first of all, everything is on chain. And second of all, you get the native protocol layer connection. So you don't necessarily need an L2 for Bitcoin, because ICP is a L2 for Bitcoin, but also it's full stack. So you can embed Bitcoin in consumer-facing applications, not just theoretically, but it is being done. Like it is embedded in, for example, OpenChat is a great example. You can send Bitcoin through an OpenChat, but you can use like a chain key version, chain keys technology in ICP. You can use an ICP mirrored Bitcoin. There is no intermediary. Like everything is on chain. You can send without fees. Essentially, without fees, you can send Bitcoin, and you can always, without intermediaries, you can transform the ICP Bitcoin back to the regular Bitcoin. There's no bridges. This is the L2, like the full stack L2, or like the infinite L2 for Bitcoin, L infinite, layer infinite then. And again, like, why isn't this talked about everywhere? Well, different reasons. It is being talked about, but most people just don't yet listen. The Bitcoin maxis might have their different incentives, even though ICP could really take Bitcoin into consumer apps fully on chain. It's the most clean and really the only way to do that. Otherwise, you can have L2, but still use a centralized application to access this and to actually use this. Like, we need UX on chain. It's not a nice to have, it's critical for DAOs. A DAO without being all on chain is not really a DAO. If you open a browser to see who are the members of the DAO or to vote on something, then if this front end is not on chain, it can be manipulated, and you can vote on stuff that is not actually real. So it's not a nice to have. Like, it's all on chain or Web 2.5 mess, or Web 2.5 consequences. So all of these versus the Web 3.0 brilliance. So Web 3.0 is the open internet, all on chain, no centralized intermediaries, transparent, efficient, solving many of the common problems at the protocol layer using decentralized databases hosted on the decentralized CryptoCloud. That's also the blockchain singularity. So we can actually write the software that is being used by humanity can be all blockchain. There's no need for like software behind the curtains, controlled by a centralized intermediary, etc., etc. So all on chain for me is the way forward. I hope this diagram and this walkthrough helped a bit. I'm not sure whether I should do maybe a mini series on top of that, but that's the way I see it. I'm looking for feedback on this, and I'm looking also just to kind of get this out there, not just within the ICP community, but outside, not just into crypto space as well, but also into the Web 2 space. Because a lot of engineers who are almost trapped here, they do their job, and they are awesome engineers who can build great things, but most of their energy is gone into maintaining and kind of surviving this empowering problems of the cloud. So getting this out there to Web 2 people, to the crypto space, to kind of really see the full context of the software landscape and how Web 3.0 is here for those willing. Ooh. Yes, that's all. Thank you for listening. Thank you for thinking along. I'm looking forward to hearing from you, and I really appreciate if you share this along and kind of think along. How can we improve this? How can we get this out there to kind of major, bigger players? That would be sweet. All right. Thank you, and have a great day. Godspeed.